Hello student, welcome to your chemistry lab. Today I am discussing reaction mechanism part 9b of organic chemistry. Today I am discussing addition reaction, that is electrophilic addition reaction. We are already discussing part 9a. Today I am discussing 9b, that is part 2 of electrophilic addition reaction. And electrophilic addition reaction, it is also very important for JEE and NEET. So read very carefully. So now watching the whiteboard. Halogenation or addition of halogen. Alkene combine with halogen in presence of solvent like CCl4 and form an addition product, a dihaloalkane. Ethene, that is X2, here X is chlorine, bromine, iodine, but here CCl4 is a solvent, form 1,2-dihaloethane. If the Br2 is reagent, it is decolorized during its addition with an alkene. It becomes a test for unsaturated compounds. Only unsaturated compound decolorize the Br2. Addition of halogen to alkene in anti-addition. Formation to trans 1,2-dibromcyclohexane. When cyclohexene is treated with Br2, confirm it, that is the reaction cyclohexene to Br2CCl4 from trans 1,2-dibromcyclohexane. Mechanism. Here first ethene, that is the pi electron, react with X2, that is halide, and form 3-member cyclic transition state, that is halonium ion. And next step, X negative attracting opposite side, that is the anti-position, form 1,2-dihaloethane. Stereochemistry of halogenation. Addition of halogen to alkene is stereospecific reaction. Different stereoisomer of an alkene give different stereoisomer of the product. And addition of halogen is anti-addition. Anti-addition of the reagent to cis-alkene gives racemic mixture of product. Here cis-butene react with Br2CCl4 form two product, that is 2S3S22-dibromobutane and 2R3R23-dibromobutane. That is the racemic mixture. And trans isomer gives meso product, that is trans-butene react with Br2CCl4 form 2,3-dibromobutane, that is the meso product. When a small quantity of NaCl added along with Br2 to ethylene, both dibromoethane and bromochloroethane are formed. And here this example, Br2 and NaCl form dibromoethane and bromochloroethane are formed, and we are explained with the mechanism. First, ethene react with Br2 form 3-member cyclic transition state, and next step, first Br react that side, form 1,2-dibromoethane, and next step chlorine react that side, form 1-bromo-2-chloroethane. Halohydrin formation. Treatment of an alkene with halogen, that is X2 and H2O, form an halohydrin by addition of the element of X and OH to the double bond. And this example, ethene react with Cl2H, form that product. And the mechanism for halohydrin formation is similar to the mechanism of halogenation. Addition of the electrophile, that is X plus, from X2 to form bridged halonium ion, and followed by nucleophilic attack by H2O from the backside of 3-member ring. Even X negative is formed in step 1 of the mechanism. Its concentration is small compared to H2O, often the solvent. So H2O and not X negative is nucleophile. And here this mechanism Cl2 form 3-member cyclic transition state. We see that X negative, that is halide ion, is not nucleophile. Here H2O is nucleophile. So H2O attack that site, form protonated alcohol, and last step is deprotonation, form ethylene chlorohydrin. Although the combination of Br2H2O effectively form bromohydrin from alkenes. Other reagent can also be used. Bromohydrin are also formed with N-bromosuccinamide, that is NBS, in aqueous solvent DMSO, that is CH3 hold 2 S double bond O. NBS serve as a source of Br2 when then goes on to form bromohydrin by the same reaction mechanism. And this is the example. Alkene react with NBS in DMSO, form bromohydrin. Stereochemistry and regioselectivity of halohydrin formation. Because the bridged halonium ion ring is opened by backside attack of H2O, addition of X and OH occur in anti-fashion, that is trans product are formed. And given example is showing that hydroboration-oxidation reaction. Another method of converting alkene into alcohol is hydroboration-oxidation. In this method, the alkene is treated with dry boron in presence of THF. This addition takes place via cyclic 4-member or 4-centered transition state. And this example, first unsymmetrical alkene, that is ethene, react with B2H6 in presence of THF, form trialkyl boron, and next step H2O, H2O2 and OH negative, that is the oxidation step, form terminal alcohol. In this case, here no convert is occur, only terminal product is formed. We are explained now through the mechanism. First ethene, first unsymmetrical alkene, that is the propene. We mark C1 and C2 carbon. Here B2H6 react in the form of BH3. BH3 is neutral. BH3 is electron deficient, that is the neutral electrophile. And first C1 carbon attached with boron of BH3 form 4-member cyclic transition state, and C2 carbon form react with BH3 form 4-member cyclic transition state. We are now see which transition state is more stable by and form a major product. And first this carbon, this cyclic transition state, it is the 1 degree incipient carbocation. Here delta positive charge is possible, that is the partially positively charged, and here steric hindrance also present. So here high energy of activation. And second transition state, that is the 2 degree incipient carbocation, and no steric hindrance is possible. So it is low energy of activation, so that is the more stable than 1 degree incipient carbocation. So 2 degree incipient carbocation is more stable, and from this and so on it form trialkyl boron. And last step, that is H2O2OH negative, and oxidation is occur, form alcohol, that is the terminal alcohol, and also form boric acid, that is H3BO3. And problem this, in this question, what is the product? It is so simple, because here in hydroboration in oxidation, no rearrangement is occur and only terminal product is formed. So it is the answer is, it is the product is this. In fact, that hydroboration-oxidation is syn addition is confirmed from the product obtained when methyl cyclohexene is subjected to hydroboration-oxidation. At this example, our product is, now we are explaining, product is two racemic mixture, that is trans 2-methyl cyclohexanol, and that is the product. Here also same question, here B2H6, here B2D6, that is the isotope of hydrogen, and from same type of product, and this is the answer. Next, oxymercuration-demercuration reaction. When an alkene is treated with mercuric acetate in presence of tetrahydrofuran, that is the THF, and water followed by the sodium borohydride and OH negative, and alcohol is formed. This is called oxymercuration-demercuration reaction. This is the reaction. Propene react first mercuric acetate, that is HgOCOCH3 whole 2 in presence of THF and H2O, that is the oxymercuration step from that product, and next step is demercuration, sodium borohydride in presence of OH negative from alcohol. In mechanism, first involve the formation of a cyclic 3-centered mercurium ion, and second stage H2O attack on the carbon atom of mercurium ion with the less hydrogen atom and ring open. Finally, sodium borohydride is replaced and replaces HgOCOCH3 with H atom, that is the reduction. And mechanism, CC double bond, that is attached to it mercuric acetate from 3-member cyclic transition state, and next step H2 attack to it this cyclic transition state from that compound, and acetate accept the proton from alcohol, that is the oxymercuration step. Last step is demercuration from an alcohol. Here is the same question, here same compound and reagent is different, and product is showing that, and product is this here. Markovnikov rule is followed, but here no rearrangement occur because here 3-member cyclic transition state is formed, so no rearrangement is occur. And extension of oxymercuration and demercuration is alkoxy demercuration. In stage 1, instead of water and alcohol is used and ether is formed. Here this example, propene in presence of mercuric acetate in THF and methanol, replace of water CH3OH from ether. So thank you. I think you are enjoying to watch my video. I think you are understanding the electrophilic addition reaction and also clear all the point. And part 1 and part 2 are also clear. So if are not clear, so comment me and I will be replied you. And I will be coming with next part of reaction mechanism of organic chemistry, that is nucleophilic addition reaction. So thank you everyone.